Hello, today we're going to discuss functions, section 1.7. Functions are related to the relation, so let's remember what needs to be a relation. A relation is mapping or pairing of input and output. Mapping, also known as pairing of input, which is x, and output, which is y. So to express this relation as a mapping, so right now it's all paired up because we have ordered pairs here. We can draw these diagrams. Remember that the ones on the left are always our x, and the ones on the y is always our, on the right is always our y. So we have negative 2, 0, 4, and 2. And then 1, 3, 1, and 3. And remember, you do not repeat these numbers in the diagrams. So negative 2 is connected to 1, 0 is connected to 3, 4 is connected to 1, 2 is connected to 3. So that's this relation shown as a mapping. Also remember that we can write domain and range for this relation, and domain would be all the x values without being repeated, and range will be all the y values without being repeated. Also, let's remember something from the previous sections, how to find the value when of y equals 5x minus 1, when x equals 2. To do that, you just have to substitute 2 instead of x, and you get 10 minus 1, which is nothing. So today we're going to talk about something called a function. A function is a different type of a relation. It's a special type of relation. It is a relation in which for one value of x there is only one value of y. So in other words, our x cannot be connected to more than one y. If our x is connected to two different y's, that is not a function. For example, if we have this setup and we connect 2 and 4, negative 1 and 1, 4 and 5, and 3 and let's say 5. This is a function because one x is connected only to one y. There is no more than one line coming out of each one of these numbers. So this is a function. However, if I connect, let's say my 3 is connected to 5. If I connect this 3 also to one more number, like 4, now my 3 is connected, my x value, my x3 is connected to two different numbers. And if it's connected to two or more different numbers, that is not a function. So once again, a relation is basically when x's are connected to y's, or input is connected to output. However, to be a function, each one of these numbers, each x number, can be connected only to one y number. If an x value is connected to more than one, like in this case, that is not a function. So let's look at some examples. Determine whether relations are functions or not. So everything here is a relation. That's not a question. The question is, are these relations functions? So if we have this set of points, the easiest way to determine whether it's a function or not is to make a mapping out of these points. So remember, we're going to put x values in the left, y values on the right. So 2, negative 1. Remember, do not repeat your numbers, otherwise we will not see what we need to see. That's the parenthesis there. 6 and 0. Same thing with the y. Do not repeat your numbers. 3, 4, 5, 1, and negative 1. Now once we have all of these numbers, we're going to connect them. 2 is connected to 3. So we're good so far. One x is connected to one y. Negative 1 is connected to 4. We're still good. 2 is connected to 5. At this point, is this a function? And the answer is no, because one number is connected to one x is connected to two different y's. We're still going to finish this up. But because our 2 is connected to two different numbers, 3 and 5, that is not a function. If you do not want to draw this diagram every time, you can also look at the set of points, and if you have an x coordinate, and once again it's all about x, that repeats more than once, 2 is connected to 3 and 2 is connected to 5, then it's automatically not a function. So you can, diagram gives you a nice visual, however you can still identify it even without drawing the diagram. If we look at these examples here, we have a diagram already drawn for us, and we can see that 2 is connected only to 2, 3 is connected only to -1, 5 is connected only to 0. So this is clearly a function because each number from the left column is connected only to one number from the right column. Now what if we have a situation like this? We have a graph that looks like that. Well, right now it's hard to tell because we don't know what the points are, but we can maybe approximate. Let's say we have this point right here. This is our x coordinate, 1, 2, 3, 4. If x is equal to 4, then it looks like it's connected to this point, which is 1, 2, 3, and also connected to this point, which is 1, 2, -3. So in other words, we have 2 points here. We have point 4, 3, and we have point 4, -3. Well, we have one x, 4, connected to two different y's, 3 and -3. Therefore, it is not a function. However, it's kind of complicated to do it every single time, to find the points and decide whether it's a function or not. And you might notice that these 2 points are lying right on top of each other. So there's actually a test that will allow us to do this to identify whether the graph, the drawn graph already, is a function or not. And that test is called a vertical line test. Vertical line test. So the vertical line test says the following. If a vertical line crosses the graph in more than one point, or more than one place, it says right there, so in more than one place, then the graph is not a function. So keep in mind, more than one place. So for example, if we look at this graph right here, we draw a vertical line anywhere. And if we draw a vertical line, then it crosses this graph twice. Therefore, if it crosses more than once, so 2 or more times, that is not a function. If we look at this graph, no matter where we draw a vertical line, doesn't matter at all. Every single time we draw a vertical line, the line crosses the graph only once. This vertical line will cross it only once, this vertical line crosses it only once, and so on. Therefore, this is a function. Same thing here. If I draw a vertical line, it crosses the graph only once. If I draw a vertical line here, it crosses the graph only once. No matter where I draw the line, it will be crossing the graph only once. So this is also a function. Now let's talk about discrete versus continuous functions. So those are two different types of functions that you can come across, especially in real life. So the discrete functions have the points that are not connected. And continuous function has points that are connected. For example, an example of discrete function is the test scores. Let's say on the first test you've got 70%, on the second you've got 85, and so on. So if we graph these points, we have first test, second test, third test, fourth test, and we have the following scores. So if we go by 10, so this is 100 points. So on the first test you've got 70. So 1, 2, 3, 4, 5, 6, 7. This is our point right there. On the second test you've got 85%. So 80, 85 is right here. Third test you've got 78. And on the fourth test you did very well and you've got 90%. However, there are no tests in between. There are no other points. It makes no sense to connect them because you have take one test and that's it. That's the only score you have. Your score is not increasing or decreasing between the first and the second test. Second test has its own score. There is nothing in between the tests. That's called discrete. You cannot connect these points. Continuous functions is, on the other hand, is fluid. It continues going. So these are more of a sample points. So let's say you're driving and you have a function where you give a time and the distance you drove. So after first hour you drove 60 miles, after second hour you already were 110 miles away, and so on. So if I graph this, and in this case we can maybe go by 50, 50, 100, 150, 200, 250. We'll be approximating these points. So after 1 hour you drove for 60 miles. You were right here. 2 hours you drove for 110 miles. After 3 hours you drove for 175 miles. And after 4 hours you had 250 miles. However, you've been driving between these hours. You didn't drive for 1 hour and then magically were at 2 hour mark. You were driving for 1.1 hour, 1 hour and 20 minutes, 1 hour and 30 minutes, and so on. So it does make sense to connect these points and continue going. In fact, you started out at 0 miles and 0 hours. So that is the continuous function because you continuously driving. You don't just pop up in different places an hour after hour. Okay, so now knowing the types of functions you can possibly have and what the functions are to begin with, we need to know the function notation. Very important, not very difficult, but yet important. So normally we write our equation in the form y equals 3x plus 2. But instead of writing y, we can use function notation. And we can rewrite the same equation as f of x equals 3x plus 2. Now keep in mind that this is not times the whole thing. F of x is the notation. It says function in terms of x. Or notice, basically we replaced our y with this notation right here. But they are the same thing. Y and f of x are exactly the same. You don't always have to use letter f. Just like a variable, it can be other letter, it can be g. So y equals negative x. In function notation can be written g of x, meaning that we're using x right here, equals negative x. Or this one we can use h of x equals 1/2 x minus 3. Once again, these letters right here are kind of like variables. What they are doesn't matter, but whatever is in the parentheses tells us what kind of a variable we have right here. And once again, they're connected. They are not multiplied. There is no distributing or anything like this. This is h of x is the entire thing, meaning function in terms of x. So basically remember, y is the same thing as f of x or any other letter there. Now why is this notation important? This notation is important so we can eliminate language. So in the beginning of the class, in the review, we had this question. Find the value of y equals 5x minus 1 for x equals 2? That's a perfectly legitimate question. However, we can write this question using just mathematical notation and using this function notation. We can say, instead of find f of x equals 3x minus 2 when x equals -1, we can say just f of -1. That notation right here tells us whatever is inside of the parentheses should be instead of x. So when I'm giving the function f of x equals 3x minus 1, and I ask you to find f of -1, that means you substitute -1 instead of x. And then we calculate and get -5. So we will say f of -1 equals to -5. Notice, we do not try to get rid of -1. It stays there. We're just saying that this function right here, when x was -1, is equal to -5. Now keep in mind, you don't only plug in numbers inside of a variable. You can plug in the entire expression. Once again, whatever is inside of this parentheses goes instead of x. So if I want to find f of x plus 2, I'm going to have 3. But instead of x, I'm putting this entire expression. So in the parentheses, instead of x, we put x plus 2. And then this -2 is still there. And then if I want to simplify this, I can distribute and combine like terms. So 3x plus 6 minus 2, which will give us 3x plus 4. However, if your number is outside of the function, like this 2 right here, that means you have 2, and then you're going to put your function in the brackets. Well, the function is 3x minus 2, but I need to find f of -4. So I have to put -4 instead of x. So 3 times -4 minus 2. But the reason why it's in the brackets, to show that the entire function is multiplied by 2. Then we use the normal order of operations. And we get -28. So once again, the key to remember, whatever is inside of the parentheses will go instead of the variable. Whatever is on the outside of the function will go on the outside of the full expression. And finally, finding values of nonlinear function. So nonlinear functions means that you have x to some power. And the idea is still the same. If I want to find g of 3, this is function g, and I substitute 3 in both x's. So it's going to be 2 times 3 squared minus 3 times 3 plus 1. And then I just calculate it by the correct order of operations. 3 squared is 9. So we get 2 times 9, which is 18, minus 3 times 3, which is 9, plus 1. 18 minus 9 is 9 plus 1, therefore we get 10. If I have a situation like this, we already discussed that if you have a number on the outside of your function, that means that you're multiplying the entire function by this number. So we have 2 times g of y, so 2 is on the outside, and instead of x, I put y now, because that's what is in the parentheses. So it's going to be 2 times y squared minus 3 times y plus 1. So I'm replacing my x with a y. And to simplify, I just distribute and get 4y squared minus 6y plus 2. And there's nothing else that can be done there. So to finish up, let's do a quick conclusion. What is a function? It is a relation where for 1x, there is only 1y. What is a linear function? We actually didn't. So it's a function that has that makes a line. That makes a line one graph. And we're actually going to talk more about linear functions in the future. And what is the difference between discrete and continuous functions? Remember, discrete means that the points are not connected. They physically cannot be connected. It will make no sense. Points are not connected. And continuous points are connected. In other words, discrete, the example of discrete function are, you have test scores. So for first test you have this score, for second test you have the other score, and so on. Or you can have values, how much something costs. You know, your calculator costs so much money, your textbook costs so much money, and so on. While continuous, it's a fluid graph. You, for example, are driving, so in 2 hours you go 60 miles, in 3 hours you go 80 miles, in 4 hours you go 120 miles, but you continue driving even between those time spans. Anyways, this is your lesson. Make sure that all the notes have been taken. If you need to go back, you can always rewind. This will be posted on my website, on my YouTube channel that you can access through the website. And your homework is the worksheet. I'll see you tomorrow.